So today I'm going to be talking about the basics of linear systems of equations and their solutions. A linear system of equations is a set of equations in the form a1x plus b1y is equal to c1. And then you also have a2x plus b2y is equal to c2. So you can have more variables in terms of x, y, and z, or you can have more equations having a1, a2, a3, a4. The system can be as big as it can possibly be. So today we're going to talk about how many possible solutions a system can have. When you're solving a system and you're finding those solutions, should that system have one solution or can that system have more solutions? So in all algebra, a linear system of equations can have three possibilities. The first possibility is that the system has no solutions at all. The second possibility is that the system has exactly one solution. The third and final possibility is that the system has infinitely many solutions. A system with exactly one solution or infinitely many solutions is considered as consistent. It would be referred to as a consistent system of linear equations, whereas a system with no solutions is referred to as an inconsistent system of linear equations. Let us look into a system where we would have exactly one solution. Say we have a system of equations as x minus y is equal to 1 and 2x plus y is equal to 6. So we're going to refer to this as equation 1 and that as equation 2. So the first thing we have to do is to solve equation 2 and by eliminating x. So how we can do that is by subtracting 2 times equation 1 from equation 2. So how you would write it is equation 2 minus 2 equation 1. So you apply that to x, y, and c. So you would apply this to this part of the equation, this part of the equation, and this part of the equation. With x minus y is equal to 1, and then saying 2x minus 2 times x gives us 0, and then y minus 2 times negative y gives us 3y. And then we say 6 minus 2 times 1, that would give us 4. So the final system that we are left with is x minus y is equals to y, and then 3y is equal to 4. So the next logical step is to solve for y. So we still have x minus y is equals to 1, and then we have y is equal to 4 divided by 3. So there we have the solution for y. Now the next step would be to substitute the value of y into equation 1 to solve for x. So we're going to have x minus 4 divided by 3 is equal to 1, which gives us x is equal to 1 plus 4 divided by 3, which is equal to 3 over 3 plus 4 divided by 3 equal to 7 over 3. So that is the solution for x. So at the end we have that x is equal to 7 over 3 and y is equal to 4 divided by 3. And these are the only possible solutions for x and y for this particular system of linear equations. Therefore, we can say this is a consistent system of linear equations with exactly one solution. We have a system of equations with 3x plus 3y equal to 4 and 3x plus 3y equal to 6. So we're going to apply the same principles we applied in the previous example of eliminating x in equation 2 in order to solve for y. So now we're going to say equation 2 minus equation 1, like 3x plus 3y equals to 4. And then we will say 3x minus 3x gives us 0. And then 3y minus 3y will give us 0 there as well, equal to 6 minus 4, giving us 2. Right? A system that looks like 3x plus 3y equal to 4, and then 0 equal to 2. This system is contradictory because 0 cannot be equal to 2. So we classify this system as inconsistent because we do not have a solution for y. Therefore, we cannot substitute into equation 1 and find a solution for x. So therefore, this system is an inconsistent system of linear equations with no solutions. Now let's look at a system with the possibility of infinitely many solutions. Say we have a system of linear equations of 2x minus y is equal to 1, and then we have 8x minus 4y equal to 4. So again, the same thing, we're going to solve for y in the second equation by eliminating x. In this case, we're going to have equation 2 minus 4 times equation 1. The system will look like this now. We're going to have 2x minus y equals to 1. And then we say 8x minus 2 times 4x gives us 0. And then negative 4y minus 4 times y gives us 0. And that is equal to, we're going to have 4 minus 1 times 4. That also gives us 0. So our resulting system looks as such. 2x minus y is equal to 1, and then 0 is equal to 0. In this case, there are no restrictions on x and y. So equation 2 does not impose any restrictions on x and y. So we can go forward to solve using equation 1. That this is the resulting equation that we have left. It tells us that the solutions for x and y are any values of x and y that can satisfy this particular equation. So this tells us that this was a consistent system of linear equations with infinitely many solutions. Let's solve it out and see. So we would have 2x is equal to y plus 1, and therefore x is equal to a half times y plus a half. Now in this case, we can put any values in the place of y in order for us to solve for x. Say, for example, we say y is equal to 3. So how we would solve it, we would say x is equal to a half times 3 plus a half. Then we'd proceed to say x is equal to 3 over 2 plus 1 over 2. X would then be equal to 4 divided by 2, which then is equal to 2. So for the value of y equals to 3, x is equals to 2. So this is one of the many possibilities of solutions that can come for this particular system of linear equations. If I had put in 4 in the place of y, I would have gotten a different solution for x. If I put in 5, and so on and so on. So this just shows that for this particular system of linear equations, there is an infinite number of possible solutions. So this then tells us that this system of equations is a consistent linear system of equations with infinitely many solutions.